Hello students, in this video we'll discover a relationship between the curvature and torsion of a curve that lies in the sphere. Let's suppose that R of S is a curve in arc length parameter which lies on a sphere. Then it must be the case that the derivative with respect to S of the derivative of the curvature over the torsion of S, the curvature of S quantity squared, is equal to the torsion of S over the curvature of S. So let's prove this. So since the curve lies on a sphere, since R of S lies on the sphere, we know that R minus some center dot R minus some center is a radius squared. And of course, this condition over here just says that the modulus of R minus C squared is equal to A squared. So in other words, the center of this circle is the center of the circle is the vector C, and the radius is A. So what I'm going to do now is I'm going to differentiate this equation with respect to S. So if we do the derivative of this equation with respect to S, do d by ds of this equation, and what will I get? Well, the derivative of r is t hat, the derivative of constant is 0, so I'm going to get t hat dot r minus c, and then another t hat dot r minus c, so I'm going to get 2 t hat dot r minus c is equal to 0. So the 2 is irrelevant over here, so that just says that t hat dot r minus c is equal to 0. Great. Let me do the derivative of this equation. Take the derivative again. And if we do that, we'll get t hat. We'll get a t hat dot t hat plus what? Plus the derivative of t hat. And what's the derivative of t hat? The derivative of t hat is what by Ferney-Soré? It's the curvature of S times p hat of S dot r minus c is equal to 0. So of course, this over here is equal to 1. And so this tells me that p hat of S dot r minus c is equal to negative 1 over the curvature of S. Great. All right, let's do the derivative of both sides again with respect to S. Take d by ds again. And what we get this time? So now let's do the product rule. So we're going to have what? We're going to have, if I do the derivative of this, I'm going to have t. If I do the derivative of the second, I'm going to get a t hat dot p. That's going to be 0. Plus the derivative of p, which by Ferney-Soré is what? By Ferney-Soré, the derivative of p is the torsion of S is negative the curvature of S, t hat of S, plus the torsion of S times b hat of S. Okay? And this is dot what? This is going to be dot r minus c. Okay? And this is going to be equal to what? It's going to be the derivative of this. So it's going to be really going to be kappa prime of S over kappa of S quantity squared, right? Because this is really kappa to the negative 1. The derivative of kappa to the negative 1 is negative kappa to the negative 2 times kappa prime. And so that's exactly what we get over here. Now we know a couple different things over here. So we know that this is going to be 0 because t dot b is equal to 0. We know that t dot r minus c is equal to 0. So this term is going to cancel out over here. And so if I divide by the torsion, this says what? This says that b hat dot r minus c is equal to the derivative of the curvature over torsion of S times the curvature of S quantity squared. That's good. That's exactly what we see over here. And then I'm going to do the derivative one last time. So let's do d by ds one final time. One final d by ds. And what we get if we do this? We'll get the derivative of what? We'll get the derivative of b with respect to S. What's the derivative of b with respect to S? That's going to be what? By Ferney-Soré, that's going to be negative torsion of S times p hat of S dot what? Dot r minus c. And then it's going to be what? So it's going to be b hat dot t hat is equal to d by ds of kappa prime of s over tau of s, kappa of s quantity squared. And now what do we know about p dot rc? P dot rc is -1 over kappa of s. So I can replace this with negative tau of s over negative kappa of s is equal to d by ds of kappa prime of s over tau of s, kappa prime of s quantity squared, and that gives us a result because the negatives over here are going to cancel out. So I have tau over kappa is equal to the derivative of the ratio of the derivative of the curvature over the torsion times the curvature squared. Thank you very much.